Then it fades into darkness. That's how the universe is supposed to work. For billions of years, astronomers believed they understood the final chapter of a massive star's life. But then they found one that seemed to ignore every rule. A star that should have disappeared long ago, yet somehow it keeps shining. Every telescope pointed toward it has only deepened the mystery. Instead of fading into silence, it erupts again and again, almost as if something deep inside refuses to let it die. Scientists have spent years trying to explain it. Some believe it's fighting against gravity itself. Others think an unseen companion is secretly feeding it. A few even wonder whether we're witnessing a stage of stellar evolution that wasn't supposed to exist. The strange object sits thousands of light years away. At first glance, it looks like an ordinary massive star. Bright, hot, violent. But its history tells a very different story. Years ago, astronomers detected an enormous eruption. The blast released an incredible amount of energy into space. For a moment, many believed they had just witnessed a supernova, the spectacular explosion that marks the death of a massive star. News spread quickly. Another giant star had reached the end, or so everyone thought. When telescopes returned later, something impossible happened. The star was still there. Not as a faint remnant, not as a collapsed neutron star. The original star itself was still shining. It had survived an explosion that should have destroyed it. Astronomers suddenly had a new name for events like this: a supernova imposter. The explosion looked almost identical to a real supernova. It became brilliantly bright. It blasted enormous clouds of gas into space, yet somehow the star remained alive. One of the most famous examples is the massive variable star known as Eta Carinae. In the 1840s, it erupted in what scientists now call the Great Eruption. For years, it briefly became one of the brightest stars visible from Earth. Many observers expected it to disappear forever. Instead, it survived. Even today, nearly 2 centuries later, Eta Carinae is still there. Surrounding it is an enormous cloud called the Homunculus Nebula. That glowing shell is made from material violently thrown away during the eruption. By studying the expanding cloud, astronomers can rewind history and estimate just how much mass the star lost. The numbers are staggering. The eruption expelled material weighing many times more than our Sun. Yet even after losing so much, the star remained alive. That alone challenged everything researchers expected. Normally, stars this massive live fast and die young. Their immense gravity crushes their cores, while nuclear fusion pushes outwards. For millions of years, those forces remain balanced, but eventually the fuel runs out. Gravity wins, the core collapses, a true supernova follows. So why hasn't that happened here? The deeper scientists looked, the stranger the mystery became. Using space telescopes and powerful observatories, they noticed that Eta Carinae wasn't stable at all. Its brightness changed, its powerful stellar winds shifted. Huge amounts of gas continued pouring into space. It was behaving like a star permanently on the edge of destruction. Yet somehow it kept recovering. Then came another astonishing discovery. Eta Carinae wasn't alone. Hidden beside it was another massive star locked in an incredibly close orbit. Every few years, the two giants swing dangerously close together. When they do, their powerful stellar winds collide. The collision releases enormous amounts of X-rays and reshapes the surrounding gas. Some astronomers began wondering, could this invisible companion somehow be keeping the giant alive? Or was something even stranger happening inside the dying star itself? Because every new observation created another question. Instead of revealing how the star would finally die, scientists were beginning to wonder if they had misunderstood the ending altogether. The discovery of the hidden companion answered one mystery, but it opened an even bigger one. If the second star was responsible for the strange eruptions, the pattern should have been simple. Every close encounter would trigger another massive outburst. Instead, the observations refused to cooperate. Some close passes produced dramatic changes. Others barely disturbed the system at all. It was as if something inside Eta Carinae was making its own decisions. That forced astronomers to look deeper than ever before. Modern telescopes began analyzing the star across the entire electromagnetic spectrum. Visible light revealed expanding clouds. Infrared cameras looked through thick curtains of dust. Ultraviolet observations exposed blistering hot gas. X-ray telescopes traced the violent collision between the two stellar winds. Piece by piece, a new picture emerged. Eta Carinae is one of the most massive stars ever studied. Scientists estimate it originally contained well over 100 times the mass of our Sun. Stars that large burn through their nuclear fuel at an astonishing rate. Instead of living for billions of years like the Sun, they survive only a few million. In cosmic terms, that's barely a heartbeat. And yet Eta Carinae has already survived an event that should have pushed it much closer to destruction. Researchers now think the Great Eruption wasn't a failed supernova. It may have been a desperate release of pressure. Rather than exploding completely, the star violently threw away its outer layers, temporarily saving itself from collapse. Imagine a pressure cooker moments before bursting. Instead of breaking apart, it suddenly releases steam. The explosion is enormous, but the cooker survives. That comparison isn't perfect. Nothing about Eta Carinae is simple. Still, it helps explain why a star can unleash incredible energy without actually dying. Even more surprising, scientists believe the companion star may have intensified the eruption by disturbing Eta Carinae's unstable outer layers during its orbit. In other words, the star may have been pushed to the edge, but not over it. Even today, astronomers watch Eta Carinae constantly. Every flare, every change in brightness, every burst of X-rays could be another clue, because eventually the star really will reach the end. When that happens, the explosion may become one of the brightest events ever witnessed in our region of the Milky Way. Fortunately, Earth is far enough away that scientists do not expect it to pose a danger to our planet. Instead, it would become an extraordinary scientific opportunity. For weeks, perhaps even months, the dying star could shine so brightly that it rivals the brightest objects in the night sky. Humanity would witness in real time the death of one of the galaxy's greatest giants. But until that day arrives, Eta Carinae continues to challenge everything we thought we knew. It reminds us that the universe doesn't always follow the simplest rules. Sometimes a star can appear to die, only to survive. Sometimes an explosion marks not an ending, but a warning. And sometimes the greatest discoveries come from the objects that refuse to behave the way science expects. The mystery isn't that scientists found a star that refuses to die. The real mystery is why nature allows such a star to survive at all. Every observation brings us closer to the answer, yet every answer uncovers another question. Somewhere inside that blazing giant, gravity and nuclear fusion are locked in a battle that has lasted for millions of years. One day, gravity will finally win. The universe has never promised otherwise. But until that final moment arrives, Eta Carinae continues to burn, still unstable, still unpredictable, still rewriting the story of how the most massive stars live and how they finally die. Perhaps that's the greatest lesson hidden in this distant giant. The cosmos is under no obligation to match our expectations. Every time we think we've reached the end of the story,